Kalau mencapai saya jangan pulang namanya.
Loh, kok hilang kau? Hah? Ujung dari mana? Tinggal nanti dua.
Setangkai kundur masa tidahan
Dipetik anak di kamar pagi.
Dan jangan timbang itu yang aku selayang pandang.
Oke, udah bisa dimulai. Oke, Bu Petra, Miss Petra. Mr.
Ya, Pak.
Wawan, sudah bisa kita mulai?
Bisa.
Nah,
Silakan.
Pak Wawan satu sudah hadir itu.
Bisa, Pak.
Makan kesini tadi Ji. Iya, ini lah belum makan. Besar-besar kali deh Ji. Payah aku buka yang lain.
Ya. Kita mulai Pak Depan. Besok di sana, ya udah sekaligus minta kopnya buat langsung apa? Pinjam terus.
Master seremoni Pak Iqbal ya?
Iya Pak, saya Pak.
Oke.
Oke, bisa kita mulai Pak.
Oke.
Pak, sebelumnya Pak, untuk Pak Wakil Rektor apakah sudah masuk Pak? Belum.
Sudah.
Sudah. Dear and Madam, may I have your attention please?
Oke.
Because the public lecture will be begin soon. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon everyone, and best wish to you as always. Thank God, I'll make because of the blessing and grace we can gather the public lecture. Previously, I would like to say welcome to Mr. Vice Rector for Academic, Mr. Prof. Arifin Gultom, and welcome to Dean of Engineering Faculty, Mr. Munawar Alfansuri Siregar STMT. Welcome to our keynote speaker, Mr. Ashok Kumar Singh, Ph.D. Welcome to moderator, Ms. Petra Venerja, Ph.D. as a moderator, and welcome to all lecture and participants have been joined in this public lecture. Ladies and gentlemen, I'm Iqbal, the moderator of today's public lecture. I'm very pleased to see you here and welcome all of you to this public lecture. Today, public lecture is about scientific development in the field of mechanical engineering, especially energy conversion science. Our agenda today is as follow: the opening MC and greeting from Dean of Engineering Faculty, University Muhammadiyah Sumatera Utara, greeting and opening the public lecture from Vice Rector for Academic Universitas Muhammadiyah Sumatera Utara. Public lecture that will be led by the moderator, question and answer, and closing ceremony the public lecture. The audience happy for the first is greeting from Dean of Engineering Fakultas Universitas Muhammadiyah Sumatera Utara for Mr. Munawar Alfansuri Siregar. Time is yours.
Okay, thank you very much to Iqbal Tanjung. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi
Alhamdulillahi rabbil alamin. Wassalatu wassalamu ala asrafil anbiya wal mursalin wa ala alihi wa sahbihi ajmain. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluh allazi la nabiyya ba'd. Amma ba'du. In this section, I try my best to speak English. I'm sorry if there is any wrong pronunciation. Bapak Ibu sekalian, pada kesempatan ini saya akan coba berbicara dengan bahasa Inggris. Mohon maaf jika nanti terdapat kesalahan dalam pengucapan. Oke, permission to speak, Vice Rector, Profesor Arifin Gultom. Your Excellency, to Mr. Professor Dr. Muhammad Arifin Gultom as the Vice Rector in Academic Department of Universitas Muhammadiyah Sumatera Utara. Your Excellency, to Mr. Ashok Kumar Singh, Ph.D., as the speaker in this public lecture today. For your information, Mr. Ashok Kumar Singh is Professor Assistant in Galgotiats College of Engineering and Technology, New Delhi, India. It's a pleasure to meet you, sir, and welcome in Universitas Muhammadiyah Sumatera Utara of this online class in this public lecture activity. I would like to introduce myself. I am Munawar Alfansuri Siregar, Master of Mechanical Engineering as the Dean Faculty of Engineering in Universitas Muhammadiyah Sumatera Utara. Thank you for your attendance. Okay. The Honorable to Mr. Ade Faisal, Ph.D., as the Vice Dean of Engineering Faculty in Academic Department, and Mr. Afandi, Candidate Doctor of Mechanical Engineering. Where is this? Where is he? Pak Mr. Afandi? Okay. As the Vice Dean of Engineering Faculty.
Assalamualaikum Pak Dekan.
Okay, thank you very much. As the Vice Dean of Engineering Faculty in Student and Alumni Department of Universitas Muhammadiyah Sumatera Utara. And then the Honorable to all leader of Department in Engineering Faculty. First of all, Mr. Chandra Asiregar, Master of Mechanical Engineering, as the Head of Mechanical Engineering Department, while Mr. Ahmad Marabdi Siregar, Master of Mechanical Engineering, as the Secretary of Mechanical Engineering Department. Then Mr. Fahrijal Turkanain, Ph.D., as the Head of Civil Engineering Department. And the Miss Rizky Efrida, Master of Civil Engineering, as the Secretary of Civil Engineering Department. Now the last is Mr. Faisal Irsan Fasaribu, Candidate Doctor of Electrical Engineering, as the Head of Electrical Engineering Department. And while Ms. Elvi Shahnur, Master of Education, as the Secretary of Electrical Engineering Department. Then the Honorable to all lecturer of Engineering Faculty. Thank you for your time to follow this public lecture activity. Last but not least, thank you for all my beloved students, which also include from Muhammadiyah Student Association or IMM, and Machine Student Association or HMJ that already participate in this public lecture activity. I hope all of you can follow this activity until the end of time, and you can take benefit or improve yourself from the speaker explanation. This activity is held to improve your scientific development knowledge in the field of mechanical engineering, especially energy conversion science. I am really appreciate to Mr. Ashok Kumar Singh in forum. After giving the explanation, please give question and answer session to all lecturer and student. And then, thank you to Professor Dr. Muhammad Arifin Gultom for the chance, and please you can open this public lecture activity. One more time, thank you to all leader, lecturer, and student of Engineering Faculty of Universitas Muhammadiyah Sumatera Utara. Especially thank you to Miss Vetra Fenireja, Ph.D, as the moderator, and Mr. Iqbal Tanjung as the master ceremony in this public lecture activity. Hopefully, this event can be success. Amin ya rabbal alamin. That all about you, my welcome speech. I hope in the next day we can collaborate again in the next research and publication paper. Thank you very much for you all. Wassalamualaikum warahmatullahi wabarakatuh. UMSU, unggul, cerdas, terpercaya.
Thanks to Mr. Munawar Alfansuri Sregar for his warm greeting and remarks, and let us towards to next agenda. Greeting and opening of public lecture for Mr. Professor Arifin Gultom. Please welcome to give his greeting.
Terima kasih pada Iqbal Tanjung ya. Assalamualaikum warahmatullahi wabarakatuh.
Ya Pak.
Alhamdulillah alladzi hadana li hadza wa ma kunna linahtadiya laula an hadanallah. Asyhadu an la ilaha illallah wahdahu la syarikalah wa asyhadu anna Muhammadan abduhu wa rasuluh alladzi la nabiyya ba'd. Especially to our honorable Mr. Ashok Kumar Singh, Ph.D, as a speaker for this moment, public lecture. Pardon me, please, sir, because I want to give my speech in Indonesian language. So, excuse me for it. Bapak Ibu sekalian, pada hari ini kita akan mendengarkan kuliah umum yang nanti akan disampaikan oleh Bapak Ashok Kumar Singh, Ph.D, dari India. Kita mengharapkan dalam kuliah umum ini akan kita memperoleh ilmu pengetahuan yang nanti juga bisa kita jadikan sebagai acuan kita di dalam proses belajar mengajar kita kepada anak didik kita dan kepada mahasiswa kita. Karena itu, apa yang dilaksanakan oleh Fakultas Teknik Universitas Muhammadiyah Sumatera Utara ini pantas kita apresiasi. Karena di tengah-tengah kegiatan sekarang ini bidang teknologi ini sangat canggih. Sehingga kalau kita mendengar India juga termasuk salah satu negara yang memang tercanggih di bidang teknologinya. Karena itulah kita memberi apresiasi kepada Fakultas Teknik. Bapak Ibu sekalian yang mendengarkan kegiatan ini nanti akan dapat bertukar pikiran bagaimana pengembangan teknologi pada masa-masa yang akan datang. Untuk itu tidak banyak yang saya sampaikan. Selamat melaksanakan kegiatan public lecture yang nanti akan dipandu oleh Ibu Petra, dan kepada kita seluruhnya yang jumlahnya sampai dengan saat ini berjumlah 97 orang, itu akan dapat berbagi ilmu pengetahuan di bidang keteknologian ini dengan narasumber kita Mr. Ashok Kumar Singh, Ph.D dari India. Saya kira ini saja Pak Dekan yang bisa saya sampaikan. Selamat melaksanakan kegiatan public lecturer. Mudah-mudahan berhasil guna, bermanfaat guna bagi kita seluruhnya. Kita buka public lecturer ini dengan sama-sama membacakan lafaz basmalah. Bismillahirrahmanirrahim. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thanks to Mr. Prof. Arifin Gultom upon his remarks, direction, and guidance. Now we enter to core agenda. The public lecture by Mr. Ashok Kumar Singh, Ph.D. will be led by Ms. Petra Feni Rija as the moderator. For Mr. Petra Feni, time is yours.
Thank you. The Honorable Speaker, distinguished guests and colleagues, fellow students, ladies and gentlemen, good afternoon. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirabbil alamin wassalatu wassalamu ala asrofil anbiya'i wal mursalin wa ala alihi wa ashabihi ajma'in. Rabbi shrahli sadri wa yassirli amri wahlul 'uqdatam min lisani yafqahul qawli, amma ba'du. First of all, I would like to welcome you to this prestigious public lecture about scientific development in the field of mechanical engineering, especially energy conversion science, which held by Mechanical Department, Universitas Muhammadiyah, Sumatera Utara. And I will be serving as your moderator today. In this occasion, we shall have outstanding presentation from our prominent speaker, whom I believe shall enrich our insight and knowledge regarding the theme of this public lecture. So before the presentations begins, allow me to introduce the speaker. Dr. Ashok Kumar Singh is an active researcher in the field of renewable energy resources, energy conversion science, and solar distillation technology. And he has received his B.Tech degree from Uttar Pradesh Technical University, Lucknow in Mechanical Engineering, and Master Tech from Maharshi Dayanand University, Haryana in Manufacturing Technology and Automation, and Ph.D. at Mechanical Engineering Department with specialization in Thermal Engineering from Delhi Technological University. Also, currently, Dr. Singh is holding a professor assistant position and as the head of the Lab of Solar Energy in Galgotiats College of Engineering and Technology, Greater Noida, India. And he has experience for 15 years in teaching and also has published 10 SEI index papers in reputed international journals and more than 23 Scopus index paper in international conferences and journals. He is also a distinguished reviewer in many peer-reviewed international journals. One of his acclaimed experience is a Commendable Research Award in 2020 and Research Excellence Award in the year 2021 and 2022, respectively from Delhi Technology University. Okay, without further ado, I will please welcome Dr. Ashok Kumar Singh to present the presentation about energy conversion science. Please, Dr. Ashok Kumar, the floor is yours.
Yeah, thank you very much for a nice introduction. Good afternoon to all, and Assalamu alaikum to
Good afternoon.
I'm audible.
Yes, maybe
Yes?
you could volume up your speaker.
Okay. So I think yeah, okay now. Good afternoon to all the respected dignitaries, faculty members, and my dear students. Here we are okay. Here we are all together to discuss about the scientific developments and related insights towards mechanical engineering and energy conversion sciences. So before we start the presentation, let me share my screen. Okay. Screen is visible, I think.
Yes, it is.
Yeah, Mr.
Okay. Well, this is a broad idea that we are discussing here, that is scientific development in the field of mechanical engineering, especially covering the energy conversion sciences. And whatever the technology involved to convert energy from one form to another form with the help of or the domain branch application of mechanical engineering. So we are discussing about its developments and different technologies. Here, there are two major aspects given in the topic basically. That is the mechanical engineering and its scientific development. And next one, the energy conversion science. Well, mechanical engineering keeps growing by inculcating different kind of aspects, scientific techniques, and fundamentals into it with the help of researches done by various scientists and researchers. And these technologies further means apply the fundamentals of mechanical engineering that covers many other branches of science into mechanical engineering, like thermodynamics, heat and mass transfer, fluid mechanics, material science. So a cumulative mind is there towards the mechanical engineering, but if we come forward with some specific or domain side of the fundamentals and the applications of these branches, so we can convert energy from one form into another form. That's how we can give a specialized mind objective, that is energy conversion science, which basically involves thermodynamics, heat and mass transfer, fluid mechanics, material science, etc. But little bit specific, especially to follow up the technology by which we can convert energy from one form to another form. Well, again, if we talk about the renewable energy science, so here two terms are there, that is the energy, which is a must required to run any system. Well, any system means the any system, whatever the living things or the universe is running, everywhere is energy, and energy is basically governs all the movements. And this is applicable to inhabitants too. And now, well, energy can retract from many of the sources. However, as I am a environment friendly personality, so I talk about the renewable energy sources. And renewable energy basically is to treat, to convert, means treat or convert the different energy that is possessed by such kind of renewable energy sources, and further treated to convert of that form into the usable form that we can means apply to make it our life convenient. So here many types of renewable energy sources are there. That is solar energy. Obviously, it is very widely used. Freely means freely available, not for is good for solar energy, but whatever the renewable energy sources are there, mostly freely available energy sources. So solar energy, by which we can produce electricity, or we can use this energy into our kitchens to cook food by utilizing different means appliances like solar cookers, etc. And then can produce electricity by applying photovoltaic modules. And then wind energy, obviously it is very versatile application that there means we are using windmills and wind turbines, etc., to produce electricity. And then geothermal energy, it is geothermal, basically a challenging energy site where more researches are going on to means harness the energy from that source. Otherwise, tidal and wave energies are again very used to produce the electricity in conventional way as well as in further going on research way. And then hydro energy is very popular again, means different types of hydro turbines are there to produce electricity. And after that, biogas. So bioproducts are utilized to produce such kind of fuels. And then biodiesels, the food plants and seeds, different types of seeds are generally utilized to produce biodiesel. And finally, animal energy. So this is one of the kind of energy by which we can utilize animals to move our things here and there and plow our fields to grow crops, etc. So out of these, every renewable energy source is utilizing independent or the sophisticated technology for harnessing the energy from these kind of renewable energy sources. Well, we can see here a broad renewable energy science is applied to harness the energy, and each and every renewable energy source requires independent technology. So here, to understand the applicability of mechanical engineering or the particular domain of mechanical engineering into renewable energy science, to convert the energy stored in that resource and came into a form of usable form of us. So there are different technologies are there. Out of that, we can discuss here as a case study for solar energy technology that is basically utilized to treat water. Because solar energy, as we said earlier, that in many areas solar energy is applied to produce energy. Out of that, solar energy is also utilized to treat the water. So here, why we are talking about water? Because solar energy is one of the kind which is freely and abundantly available around us, which can be utilized to treat the water. And as renewable energy concern deals with the science that involved to apply mechanical engineering into the technology. So here we will talk about the solar distillation technology that is governed by the solar energy. And now the next important point, why we talk about water. And here, as the inhabitants or whatever the human being's body is made, have more than 70% of water basically. So water is one of the essential part for the survival of inhabitants. So it is a very careful element that we must bother whatever the amount around whatever the amount of water available around us should be as pure for the direct consumption. But we all know that the available water within the human reach is mostly either contaminated or brackish. So this is the main reason that treatment of water is quite necessary. And as the freely available solar energy as well as wind energy is there, this kind of technology is quite economical, self-sustainable, and most importantly, eco-friendly. Now, come to the very fundamental about the solar distillation technology. So it basically utilizes solar energy, and if we talk about a general classification of this, so it may be of a single slope that is oriented towards south, or maybe double sloped that is oriented towards east or west for the better absorption of solar radiation throughout the day. And this technology basically requires impure water, solar energy, along with the wind energy for the betterness or for the better performance of the solar distillation technology. Here we have coined this word as solar desulfication technology also. And obviously this produced potable water can be directly used for drinking water, agriculture and industrial purposes. And to make it more healthier, we may add some minerals into it also. As we see in the local market, the packaged drinking water have some additional minerals are there. Otherwise, the direct consumption or good quality of water can lie, means that lies under the 7 to 8 pH with 200 to 1000 ppm total dissolved solids, and which is treated as a good quality of water for direct consumption. Now here table shows the water distribution on Earth, in which we can see that the ocean reserves most of the water, and the bad part of this is most saline water is there. Well, this is not as bad as we talk about, because this is also required to run the ecology properly. Otherwise, whatever the fresh water available around us, less than 1% water is within the human reach. And out of that less than 1% water, mostly brackish we can say, or even intentionally contaminated, as industrialization and deforestation are there, and many concrete buildings or concrete forests are created day by day. That's why the pure water gets contaminated. Now come to the necessity part of fresh water. Basically, it should be nearly 1700 cubic meter water that is required for a person to survive in a year properly. And less than that is called a water stress situation for that continental zone. And less than 1000 cubic meter water is basically treated as water scarce situation, and less than 500 is treated as absolute water scarcity for that region or continent. And such kind of situation basically treated as a parameter, measurable parameter, that is called water stress, which arises due to the imbalance in between the quality and quantity of potable water in terms of demand and supply imbalance. So basically, classification of water is fresh and brackish. Otherwise, intentionally contaminated water is also be there, that is called contaminated water. Here, brackish water can be further divided into light, moderate, high, and seawater. And seawater have the extreme salinity. And now, come towards the specific technology that are using in the solar distillation technology, which is basically means influenced by this atmospheric distillation process as represented here, in which the solar energy is basically consumed by the exposed water bodies and gets evaporated, that forms vapor and cloud, and after condensation from the evaporated form of water gets back in the form of distillate that is reserved over the different water reservoirs. And the whole cyclic process is basically utilized or gives the fundamental by which solar distillation technology governs. But there, a close proximity within the sealed chamber, this phenomena is happening. And now come to more specific about the solar stills or the solar systems. So there are many solar systems are there, like solar desalination systems utilized to treat the water, solar dryers to dry different consumable items, etc. Water heaters basically utilized to heat the water, and thermal collectors and reservoirs to improve the performance of the systems. And now again, moving more converge, here we have solar desalination system basically of two types, that is passive and active. And passive and active, just like every system itself working or producing a distillate is called passive, and if we push that system by utilizing additional elements or electrical compliances are there, are called active solar desalination system. And these systems are also maybe of a single or multi-basin type, single or double slope type, or inclined or novel design type. And these systems may or may not utilize additional functioning elements to perform the or to improve the performance of the system. And those additional functional elements may be different kinds of fins, external condensers, sprinklers, fans, different types of lenses, and phase-change materials, photovoltaic thermal materials, means modules to produce electricity, evacuated and rescue collectors, etc. And now this picture shows a conventional single slope solar desaltification system. So basically this conventional single slope gives or represents a basic technology by which we can treat the water with the help of evaporation, condensation, and distillation process, as we have seen in the earlier slide that follows the open or distillation process happening in the atmosphere. So here we can see that whatever the solar energy incident toward the top glass cover, so based on the glass cover reflectivity and absorptivity, rest part is transmitted into the basin chamber, where again the same phenomena is happening with the basin water, and finally attenuated partial solar radiation is absorbed over the basin liner. And the red lines marked outside shows the information about different kind of losses happening outside the basin chamber in terms of convective and radiative heat losses. In the same way, over the basin water surface, convective, evaporative, and radiative heat losses are there. So that's how the conventional single slope solar desaltification system acts. So whatever the vapor forms into the basin chamber is just hits the condensing or the inner surface of top glass cover, where condensation happens by losing its latent heat, and then the condensed water trickle down, and which is covered outside the chamber in the specific containers, and that is or distillate water that is directly consumed in various fields, along with the direct consumption to us also. Now, that's conventional solar desalinification system have many deficiencies which keep improving, and that's how we call it as the development of technology. So as the today's public lecture is concerned about the development in mechanical engineering, and more specifically it is concerned to the renewable energy sciences, and that science basically deals or influenced by the mechanical engineering basically. So here we are trying to establish the relationship between the energy conversion and the mechanical engineering, certain domains of mechanical engineering, by means evaluating the solar desalinification system. Now, what the conventional solar desalinification system is, there we have the performance of the system must be improved by incorporating certain solar collecting devices or other devices that may improve the performance of the system. So here a classification for evacuated tube collectors are given there. That is basically utilized to our system to improve the performance of that in terms of distillate output basically. So here we can see evacuated tube collectors are basically 4 types, that is cover collector type, annular tube collector type, and heat pipe type, and finally U-tube type. So this evacuated tube collector basically carries annulus tubes in which vacuum are there, and if the inner tube carries heat pipe is called heat pipe type, and if it carries U-tube, that basically is treated as evacuated tube collector with U-tube. And even if this evacuated tube collector forms a cover over the flowing water or air, that is called as a cover type evacuated tube collector, out of which the means present technology covers the evacuated annulus tube. However, such kind of tubes are also utilized by many researchers, that is mentioned here, like Wharton tube type with external mirror type with cusp reflector type. And now many more solar thermal collectors are there, like flat plate collector, that is basically means have high heat losses and requires solar tracking, and also to improve its performance active devices are to be attached, and that's why the overall maintenance of such kind of flat plate collectors are increased. And then evacuated tube collector, it has a circular or cylindrical shape that doesn't require any solar tracking, and thermosiphon basically applies to means for its functioning. That's how the maintenance as well as the means care cost deducted for the evacuated annulus tube collectors. And also due to evacuation, it has least thermal losses. And now if we talk about other type of collectors with cooling effects that may solve deposition problem may be there, and due to which performance of such kind of systems may be reduced. And then photovoltaic modules have its benefits because it produces electricity which is finally utilized by electrical appliances, and in this way the overall system embodied energy improved, or improved is not good to say, but increased we can say. And now phase change materials are better in cloudy situations, wintry and off light time situations. And if we talk about nanoparticles, so it basically good for thermal conductivity but bad for the exposed surfaces because it may corrode the system and even harmful for health and require intense monitoring as well. That's why it is not better for remote areas. So here we can see a comparative observation for different kind of thermal collectors, out of which evacuated endless tube collector respond better. That's why we are means referring here evacuated endless tube collector. And now a general observation of the systems, basically conventional solar desalination system assisted with different types of evacuated endless tube collectors are representing here to just focus on its development and the performance improvements. That's how we can conclude that how how the pace of development is moving on in the field of solar decertification technology. Here we can see that in the earlier researches, many researchers applies large number of evacuated tube collectors assisted with their solar decertification system. So obviously, large number of evacuated tube collector may improve the percentage increase in solar receiver areas, and obviously it increases the respective amount of thermal gain to the system that improves the overall performance of the system. And the dark side of the such kind of systems are there, means we indirectly increase the loop of the water movement, and then a large number of EATC improves the embodied energies as well. And such kind of evacuated tube collectors that have imbalanced or unoptimized utilization of EATCs may also motivate us to do with another design. That's how we are looking here. Different researchers may just reducing the evacuated tube collectors numbers, as mentioned here in the Dev et al. And Sampath Kumar, again, then Singh et al. These persons are reducing the number of tube collectors. Finally, some of the researchers may also reduce the number of collectors in a huge amount, that is 1, 2, or 5 number of tube collectors are also being used by different researchers with moderate performances of their system. But again, the applicability or the maximum utilization of such evacuated tube collectors be left there, which can be further improved by utilizing some utilizing some additional subordinate materials, or reflectors or mountings, etc., which may be which we are discussing in the later slides. So in this way, the overall glimpse of the performance observations targeted to the solar decertification system assisted evacuated endless tube collectors gives generalized information on which we can put some recommendations that a thermosiphon is the one of the best way by which system is governed, um, without applying any additional energy, that directly reduces its embodied energy as well as maintenance cost. And next is the utility of EATC with its ultimate performance by utilizing additional parabolic concentrators assisted to those EATCs may improve the performance of the system. And finally, as EATC we are using here, so thermosiphon loop is there, so we must monitor over the thermosiphon influenced by the solar insolation to take benefits of the circulation rate accordingly.
Pardon
Now
me.
here,
Sorry to
pardon?
interrupt. Your time is only 5 minutes left. Thank you.
Okay. So, actually, we don't know about the presentation time. That's why my pace was quite easy. So
Sorry, my
now,
mistake.
okay. So here, two basic systems are there, which we are going to just subordinate with the solar desalination system, that is evacuated and tube collector, along with the modified parabolic concentrators. Here we can see that left and right side orientation of CPCs may enlighten or the eliminate the sides of the either sides of the evacuated tubes, and the cusp compound parabolic concentrator will eliminate the bottom half of the EATC. In this way, the overall EATC is basically eliminated uniformly around its periphery, and that's how we can confirm the optimum usability of this EATC. Because the EATC basically utilized to receive maximum solar radiation around its periphery over the selective absorber coating, which is placed over inside the inside outer layer of the EATC tube. And now, obviously, this system is responsible towards the society in terms of a greater yield, and obviously self-sustainable and eco-friendly, because every system must be responsible to the environment and the society by leaving at least adds the after effects to impact the society, and proficient geometry obviously may improve the performance. And now here some mathematical and mechanical aspects that includes the basic thermodynamics, first law, second law, and the fluid mechanics applications into this. In this way, we can connect the mechanical engineering to the energy science conversion. So here, the solar energy radiated over horizontal surfaces basically converted into inclined surfaces by following these equations. So as time is not allows to explain these, so now finally to construct our system based on the fundamentals as we apply based on mechanical engineering different domains. So here are some of the assumptions. That means system may be causes steady state airtight leak proof, and EATC must be identical and do not disturb any adjacent tubings, etc. And then thermal model analysis is a must, which follows the fundamentals of a specific domain of mechanical engineering to construct the solar desalination technology. So here we have parallel array NEATC and CPC, which follows the thermosiphon loop. And this thermosiphon loop is basically interferes the temperature difference, whatever we have a temperature over the selective absorber and the temperature containing water mass into the EATC, and that is calculated by following these equations. Basically, selective absorber temperature is followed by equation 2.2, and this way final temperature is followed by equation 2.5, and final heat transmission from EATC to basin chamber is calculated by equation 2.6. And similarly, we can form energy balance equation to calculate different temperatures into the basin by following the ambient exposed surfaces energy balance equation, condensing surface and their energy balance equation, water mass, and the basin liner energy balance equations. In this way, we can calculate the inside temperature, outside temperature, basin temperature, as well as the water temperature. And finally, we can calculate the mass circulation rate by following equation 17, which is obviously depend on the aspect ratio of EATC, its orientation and number of tubings and the solar radiations, etc. And performance basically covers, means whatever the thermal model we have discussed there with the help of mechanical engineering and some sort of mathematics there. Finally, we have to calculate its performance, and this includes the yield, output, energy gain, and the respective efficiencies. That is based on energy exergy, which is followed by these equations. And then the overall applicability of the system is basically governed by energy matrix analysis that means offers its usability. So energy matrix analysis basically have the payoff time and factor and life cycle conversion efficiency. And finally, the productivity of the of the system basically defines its feasibility, and which is a ratio of overall revenue earned by the selling of yield to the TAC. Here TAC basically is a part of economic study by which we can calculate the overall selling price of the yield prepared by the produced by the technology. And then enviroeconomic analysis is a must for every technology, because whatever the energy we are producing by any of the technology leaving its byproduct, and that may impact the society or environment in which we are living. So here we can calculate the emission of pollutants, basically carbon dioxide, sulfur dioxide, or and nitrogen oxide, and this gives equivalent information about emission of such kind of pollutants, which may be further replicated by the mitigates of those pollutants, and these mitigates may be credited out in the international market based on its credit value and called as carbon credit revenue, which is the indirect benefit given by the system. Here are the inputs. Solar intensity distribution, that is a basic input given to the system, and that's how this figure gives the information. That's how we can calculate the number of EATC associated with that system. And here finally the performance observations we are looking yield was quite appreciable, and that is following the temperature difference and mass flow rate accordingly. Booming around 2 p.m. where the solar intensity is quite high, and then energy exergy efficiency is representing again appreciable, which is following the energy efficiency basically following the yield production. Otherwise exergy efficiency, which gives the quality information of the system and shows a diminished performance where the temperature differences are high, because at this time exergetic reversibilities are quite higher in the system inside the different components of the system. And here the utility of the system mentioned by energy matrices and life cycle conversion efficiency again gives a better information. And then figure ABC for the annual productivity, which is more than 100%, that justifies the system for its feasibility. And now concluding remarks for this case study, obviously we whatever the topic we have taken here to discuss based on the development of mechanical engineering as well as the energy conversion sciences, this technology means if we apply some sort of high performance components to the system, obviously that may improve the temperature, yield, efficiency, and overall performance of the system. Ultimately, we must have to calculate the environment friendly aspects, means how much emissions of pollutants are there and mitigates are there. And productivity of the system also must be checked for its feasibility, because feasibility and sustainability is one of the major concerns to survive in the competitive market. And here are the comparative observations for different systems also based on its solar exposure. So before I conclude my views and insights regarding this topic, so I would like to convey my opinion that all must go towards the what we can say renewable energy sources, because these are not only freely available to us but also motivates us to just utilize these resources in a conscious way. And here conscious way basically major term we focus on, because whatever technology we are using to harness the energy is available in that system or in that renewable energy sources must be focused about its byproducts, because these byproducts may harm our system. So we should check in whether that technology is up to the mark in terms of ours, or in terms of the health, issue of the environment health also. So finally, well, I would like to thank and express my sincere thanks to my near and dear Bhavan and the Dean of Engineering Faculty, Monawar Alfansuria Seraga, for offering me to share my thoughts and insights on such an interesting topic related to energy conversion science. So once again, thank you all. Thank you very much.
Okay, thank you very much, Dr. Ashok Kumar, for the very detailed elaboration about desalination of seawater with solar energy. Okay, and I'm sorry, my apology for not informing time allocation in the beginning. Okay, now we can proceed to the Q&A session, and I will addressing one question at a time, because just in case if there's need interpretation. Okay, so please, who wants who have question for the Dr. Ashok Kumar can hit the raise hand button in the at the bottom. Okay, please, anyone? Any question? Okay, one question at a time. First, Wawan Setiawan Damani.
Okay, thank you, Ma'am Petra, and thank you, Sir Sokumar. Maybe I have a question. Maybe number one, we want make a solar collector that don't still use angel. You know, we think our country that are across the equator and don't need the use angel because they get the full amount of sunlight. What do you think about this?
Just repeat the question. What do you want to know specifically?
Yes,
because more or less the solar brightness as depends on the latitude what you are using in your system. So that's why one term I have utilized, that equivalent amount of solar radiation over the inclined surface, and that is converted, whatever the amount of solar energy hits the horizontal surface must be converted into the appropriate angle.
Yes, we think our country that are across the equator, but we don't have use angel for the another country, 50 degree or 30 degree, and because they get the full amount of the solar energy. For solar distillation, we have tried the solar steel model several times, but we have a problem when the heat energy receipt is too large. This affect the condensation rate. Then we try to cover the outer surface of the glass so that the sunlight does not enter. We use a special collector to draw heat energy. What do you think about this?
Okay, well, to improve the condensation process, you just need not to just acquire more and more solar energy, because when we just acquire more and more solar energy, it no doubt improves the evaporation process. And if we see about the vapors that are excessively trapped into the basin chamber, and it may also create vapor pressure there. And in this way, the amount of energy, whatever amount of energy basically trapped into the vapor, may be further utilized, means negatively utilized to recondense the distilled water, means, or we can say the condensed vapor, it gets recondensed by the, means, whatever the heat trapped into the vapor. So we have to whatever amount of solar energy we try to absorb, in the same time we have means supply some additional condensing chamber there to improve the distillation process or condensation process.
Doctor, I think at the beginning, Mr. Wawan asked if since we are in the equator, so we have maximum solar exposure all year round. Is there any chance that our efficiency is higher than the other country who's not in the equator?
Well, efficiency parts are two types, that is energy efficiency. Obviously, energy efficiency may be higher for your devices placed there, but exergy efficiency must be improved. So this system by default have a very low exergy efficiency. So no doubt your system may have the energy efficiency higher than other continents or locations because of the better solar exposure there.
Okay.
It means collector is very important. Yes, sir.
Yes, of course.
Okay, maybe I have one more question for.
Okay, please.
Wind energy, sir. What is your advice if you want to use wind energy at low speed? You know, is our weather in country by using the type of airfoil or the type of turbine, sir.
Okay, means in terms of solar collector, I mean to means you want to say.
Yes, we use vortex turbine and vertical airfoil. Use NASA 4112. It's I not work.
Means airfoil for what? Airfoil for solar distillation system or something?
One turbine, sir.
Windmills, yeah.
Yes, for wind.
Yeah.
Okay,
windmills. Yeah, very good.
What is your advice if I want to use wind energy?
Yes, okay.
Low speed.
Well, wind energy is basically utilizes through its wind streams basically. So means sophisticated design. What we are available, that is, different types of windmills are there based on this technology. So you can go for that, or otherwise just you have to improve means if new design you choose, you must go how to decrease the drag and thrust. So you can merge 2 or 3 designs in your own design to prepare novel design, because just if you try to prepare a new design, obviously is a difficult task, because many researches have been already done in this field to just harvest the energy from wind or wind stream actually.
Okay, sir. That means the airfoil is important to design.
Yeah, definitely.
Apply to the.
Okay. Is that enough, Mr. Rowan? The answer clear enough?
Okay, Miss Petra, clear.
Okay, next question from Dr. Joseph, please.
Yeah, thank you. Hello, Doctor. Dr. Ashok Kumar, thanks for your exposure just now. It's very, it's a good idea, but this is not my field. But your exposure is very interesting for me. So I would like to ask you about some question here.
Yeah.
Okay. First, how in India develops renewable energy overall? In particular, the research carried out in universities and its impact on the general public. The second question, what is currently being done regarding renewable energy research? So the third one, we know the seawater desalination, that is not a new method. We know this method already exists before, as we saw in the Middle East. So maybe you can give us something new, maybe just the another method or something else. I think that's Dr. Ashok. Okay.
Yeah. Yes, of course, we all know that this technology is existing quite a long years ago. But here we are talking about the stages of development, because still this kind of solar desalination technology is under development. And in India, renewable energy sources are quite, accelerated in a due period of time. And also many of the research papers I have also reviewed from Indian scientific bodies like CSIR is one of the scientific body in India. So they are practically, developing such kind of solar desalination technology that is located remote in around remote areas, or we can say near the oceans.
Okay, so how many percent the renewable energy can applicate to the general publics in India? So the the result of the university research, how can be impact to the general public?
Well, still is on the percentage is not much appreciating, because we are just moving towards the from conventional to the renewables, like solar energy and such kind of solar renewable technologies, desalination technologies, like how conventional petrol or diesel operated vehicles are converting into gas or even LPGs or CNGs, and further it is moving towards the battery operated system and then solar operated system. And meanwhile, if we talk about the such kind of distillation technology, of course, a huge plant is implanted by the government of India. So we are just developing in that stage. So hopefully in coming years we are more dependent on the renewable energy systems and technologies.
Okay, so maybe the situation is still same with Indonesia. Still,
Yeah.
we still use the
Yeah, that's why
what's
this topic is that's why this topic is quite required to discuss among us, because everyone should know what are the consumables are there is not for every time, so we must move over the renewables.
But desalination is very important and interesting, I think. Okay, thank you, Dr. Ashok. Okay,
thank you very much.
Okay, another question. Anyone? You can also write the question in the chat section if you want. Okay, waiting for the question. I think energy conversion leads to energy conservation, right?
Yeah.
And I think it can make an impact to the lessening climate change. Because as we read, as we saw, as we heard in the news recently, there are a wildfire in the US, Canada, or a heat wave in the Europe as the result of climate change. So how do you see this energy conversion can overcome this problem?
Oh, well, the situation basically not directly to the such type of renewable sources we can move on, but here certain issues that what we are doing with our forest, with our soil, with our water, if we just consciously live or this mother earth planet, so I think such kind of situations mostly means not as severe as we are looking in these days.
Yes, I agree. And the goal is right from your presentation is one that interests me more is self-sustainable. Self-sustainable in energy, self-sustainable in what else?
Yes, means self-sustainable. Just we want to tell here is the system that requires its self-existence. Means that's how if we do not apply severe or intense monitoring for the operation, or we just impart at least maintenance cost, and whatever the solar collector is there is automated when the solar energy is there. It get like means self-sustainable. Again, we can see like such kind of street lamps which are automatically lit at the evening throughout the night. So, and whatever the solar energy that system received around the clear day is utilized on the night. So in this way, such kind of system we should produce. So here the technology what we are discussed is treated as self-sustainable, because the thermosiphon what we are preparing with the help of EATC is basically utilizes its energy around the day, and the excessive water mass which is stored in the basin chamber is basically utilized for the nocturnal yielding. In this way, the diurnal and nocturnal yield accumulates huge performance to this system. That's why just term self-sustainable is given here.
Okay, and the question is, in the end, can we completely shift from the soil fossil fuel to the completely green renewable energy?
Obviously, this is not possible because we are such kind of technologies are not there to just fulfill our requirements. That's why we are looking for the forests to cut down the trees for our requirement, to pollute the water for our requirement, and in the same way to pollute the our soil to improve the grow more and more crops in there. So because these are the after effects what we are creating by increasing the population and the increasing our requirements, and our lifestyle is also one of the major aspect that we are facing such kind of adverse situations nowadays.
Yes. Yes, the technology is not there yet, but I think the goal is to try to shift the fossil energy to the green energy.
Renewable. Yeah, definitely.
Okay, anyone? Another question, please? Okay.
I think cannot question again.
Pardon me, what? Iqbal, what? Okay.
I think cannot question. Pass.
Okay, since there's no any more questions, maybe we can talk about the future plans between UMSU and your institution. Is there anything that you can suggest that we can do in the near future?
We have many plans like research projects are there we are doing with our students in our college. So later on we'll discuss about such kind of projects that we mutually go with.
Okay, do you have something in mind right now, like right now, that we can follow up in the near future?
Well, the overall experience is quite great for me because such an energetic personalities are there in in your university, which are focusing towards such these researches and such renewable energy technologies, and also offering such kind of proposals and mutual collaborations. So all these are positive features for me. So in this way, we will move on with a type of collaborative research and project work in the future.
Okay, if we had a joint research, our university will be pleased to provide the budget, and maybe if the research was will be done here, the university will please to provide everything for you to do the research.
Yeah. Okay. So we'll make the all the required steps. We'll take the all the required steps to prepare a project, research project basically, and accordingly, I want some time to discuss with the director of our institution to make a memoranda or the MOU for this kind of project. So later on, we'll definitely discuss about the research projects.
Okay, so maybe there's our dean will reach out to you and do the correspondence directly to you.
Definitely. Yeah, definitely.
Thank you, Doctor.
Thank you very much. Thank you.
Okay, since there is no question, we can close this public lecture session with the closing remarks that the energy conversion that leads to the energy conservation is often the most inexpensive solution to the energy shortage, and it is more environmentally kind alternative to increase energy production.
Sorry, Ma'am Petra, there are questions from our student.
Pardon me, what?
Aditya Angga wants
Oh, so sorry, Dr. Ashok Kumar. There is one student who wants to ask question to you.
Oh.
Hello, sir. I introduce myself. My name is Aditya Angga Prahma, and I come from in University of Muhammadiyah Sumatera Utara. How to remove
Hello, Aditya, please address your question.
My question is about how to remove the salt component in sweeter. What process is used? Thank you, sir.
Repeat your question.
How to remove the salt from what, Aditya?
My question is how to remove the salt component in sweeter. What process is used?
Okay, well, salt deposition is means a huge issue for such kind of technologies. So there are many methods are there. Means some additives we can use within the water. You know, this technology is again not new because chemicals are there which may just try to just means resist for scale formation. One technique may be this, and second one is the we can go for the turbulent type of effect there, or a stirrer we can use into the system by which scale gets descaled during the evaporation or distillation process. So in this way, many techniques are there, or even if we increase the maintenance cost, so there is no limit to remove the scale from the system, but this is not economical. So we can go for the additives that are used in water bodies, and some sort of turbulency or the stirring elements are there utilized in the basin. In this way, we can reduce, means not 100% we can descale the formation of such kind of salts, but okay, mostly scales gets removed by these technology or these means efforts.
Okay, I'm Aditya.
Thank you.
Okay, the answer is clear. Another question, maybe from your friend? No? Okay, so we can close this public lecture session, and I will give it back to the MC, Iqbal.
Okay, Miss. Thank you for Mr. Ashok Kumar Singh for the very interesting materials. Hopefully, may be useful for all of us. And thanks to Miss Petra Finirija that have been led the public lecture. Let us give applause. The audience happy, finally we come to the end of the agenda. I ask the presenter sorry if there are mistakes in bring this event, and let us close the event with pray may the event which we have to solve is beneficial for all of us. Amin ya rabbal alamin. I close this agenda. Assalamualaikum warahmatullahi wabarakatuh.
Oke.
Foto. Please take a picture.
For all participants on your camera. Aduh, masih. Who take a picture?
Thank you, Sir Ashok Kumar.
Iqbal, jangan nampak kepala aja lah Iqbal. Tak jelas. Masa ini hidung ini keluar Iqbal.
Okay, well, so maybe leave.
Okay, thank you so much, Mr. Ashok Kumar Singh.
Thank you so much, sir.
Use one in other agenda.
It's a great pleasure to share our ideas with you all.
Okay, thank you, Doctor.
Okay, now, thank you. Thank
Permission
you
to
very much.
leave.
Yeah.
Thank you all. Thank you, Undo, Sriasbiati. Thank you.
Thank you so much for all participants.
Thank you, Pak Yani.
Thank you, Bu Sri.
Undo Sri kok background virtualnya beda ya dari yang lainnya.
Lagi di tengah sawah.
Muhammad Adam kenapa baru bertanya ini?
Bertanya nggak perlu dijawab itu.
Ditutup pula sama Adam.
Itu kan bertanya, nyerah dan nyerah, angkat tangan. Okay, thank you all. Izin leave.
Izin live ya. Yang selesai. Izin live ya.
Iya, Bu.
Sudah bisa live ini Bapak-bapak.
Sudah, Bu, sudah. Sudah selesai kita, Bu. Nah, ini tim kita ini, Bu. Nah. Yang ketahuan, Ji. Ji, bateraimu habis nih, Ji.